Discuss a problem on LeetCode. It's a easy problem on regarding bit manipulation, and this problem wants us to check whether for a given positive integer, if the two adjacent bits in the binary representation always have the same value. If they have the same value, return true. If don't, return false. So for the number 5, its binary representation is 101, and you can see that the adjacent bits are different. But for number 7, it is not, right? So the problem description is simple, and our strategy is also very simple. So we're going to iterate through the number. So and we want to iterate the number of times of how many digits are in the binary representation. And for each iteration, we want to compare the current position, the bit in the current position with the bit in the next position. And if they all have different values, then we can return true. If one set have the same value, then we have to return false. We could just short circuit the for loop. Okay, so the first thing we have to do is we have to figure out how many times we have to iterate through the loop, right? So this could be done many ways, and today I want to do it using some simple math. So first we're going to import the math module, and we're going to set the number of times to be, we want to log the number with base 2. So this will give us the number of, so for 5 it would be 2 raised to the what power will give us 5. So this number is going to be between 2 and 3 because 2 raised to the second power is 4, 2 raised to the third power is 8, so 5 got to be something in between. But this is not going to return us an integer value because 5 is not a full power, it's not an integer power of 2. So we can either round up or round down. You could do it either way, but in this case we want to round down. So we're going to floor for this value. So this means that for the number 5, we would iterate through this loop 2 times, and for the number 11, we would do it 3 times. And we will see why we choose to round down once we have written this for loop. So now we enter the for loop. Again, there's many ways to do it, but this is the way I choose to do it for this solution. So for range D, so in each iteration we want to extract out the current digit, and we want to extract out the digit after. So one place to the left of the current digit, right? So so for example, in the first iteration we want to extract out this and this. And how are we going to do it? Well, we know that we could extract out the digit by doing some shifting, and we have discussed this in the videos before. And this is for the digit to the right relatively, and we want to also extract out the digit to the left, which is my bad. So notice that we are keeping n the same, so that we have to rely on the index to access the actual place in the digit. So we want to shift it by this amount for the digit on the right, to the digit on the relatively to the left. So n1 would be this digit for the first iteration of the number 5, and n2 would be this digit. Okay, so then we extract out the digits. We want to compare them to see if they're the same. So we want to return true if the 2 digits differ. We want to return false. No, we want to return false if they differ, but we want to keep checking if they're the same. So remember that the operator that will give us true if the two digits have the same value, the 2 digits have the different value, would be the XOR operator. right? So we simply use the XOR operator to check whether they are different. So if they are the same, so in other words, if the XOR returns false, then we would simply return false, because if one of them one pair have the same value, then this this number doesn't have alternating binary representation. So if every pair checks out, then we would return true. So if the for loop exits normally, then we would return true. Okay, so now you can probably see that why we choose the 4 is because we don't need to get to the last digit, because the last digit is only compared once to the digit before it. So we already achieve it by getting to the digit before it, and we have checked the last digit already, which is the last pair that we need to check. So we don't actually need to sealing it to reach the last digit. And that is all the code for the problem, and we just want to run it to see if there's any problem with it. Okay, and we want to submit. Okay, so that is all for this problem.